Welcome back to the Deep Dive. Today, we are getting into a massive stack of sources you sent us, and they all point to what might be the most important hardware project Apple's had in years.
Oh, absolutely.
We're talking about their secret weapon in this whole AI arms race, a server chip with the codenamed Baltra.
That's the one.
So our mission today is to, cut through the noise. We want to understand how this chip isn't just about saving money. It seems designed to completely rewrite the rules for cloud AI.
It really is a fundamental shift.
We're going to dissect the tech, the memory architecture, which is fascinating, and see how this thing stacks up against, say, Google or AWS.
And it all ties back to Apple's biggest promise,
Yeah.
privacy. This chip, Baltra, is the physical cornerstone of their private cloud compute program, their PCC.
It's really the logical conclusion of Apple's whole philosophy, isn't it? Vertical integration.
Exactly. They did it on the device with the A-series and M-series chips. Now they're extending that complete control right into the data center.
And the motivation here is twofold.
Right. There's the economic side, escaping what people are calling the Nvidia tax. The cost of these high-end GPUs is just spiraling.
But that's not the main thing.
No. The main thing is existential. It's security. They realize they just can't make their core privacy promise if they're running on hardware they don't fully control.
So the money's a huge factor, but the real driver is ideological.
Precisely. Apple's entire brand rests on that promise of privacy. So Baltra is the physical answer to that promise. It's how they can deliver really complex AI without, compromising on that core value.
Okay, let's unpack that.
Yeah.
I mean, Apple has always been the champion of edge computing, right?
Yeah.
AI running locally on your device.
Mm-hmm.
But they can't escape the reality that these huge new foundational models, they just need more power.
Yeah.
A lot more.
It's an inevitable evolution. You have to move to a hybrid model. The sources are really clear on this. Baltra is the hardware built for that exact hybrid cloud and edge architecture.
And that's where private cloud compute, or PCC, comes in, to make that hybrid model secure.
You got it. The technical goal is something they call stateless computation and non-targetability.
Okay, let's translate that. Stateless computation. Does that basically mean my data hits their server, does its thing, and then vanishes? It leaves no trace that could ever be tied back to me.
You've nailed it. No logs connecting a query to you. And non-targetability means that even if someone physically broke in and stole a server rack.
Which is unlikely, but...
Right, but even if they did, the data running through it is so fragmented and temporary that it's useless. It can't be pieced back together to identify any one person. It's security by design.
And structurally, Baltra isn't the main brain of the server. It's more like a dedicated muscle chip.
That's a great way to put it. The roadmap shows Baltra is a pure AI accelerator, a GPU. It's just for matrix math. It works alongside another chip they've codenamed Sotra.
Sotra being the CPU.
Exactly. Sotra runs the OS, does the scheduling, and it just frees up Baltra to be laser-focused on one thing, making AI tasks go fast.
Okay, so if that's the architecture, let's get into the blueprint.
Yeah.
What's so different here? Because it seems like they're flipping the script on what Nvidia prioritizes.
They are. This isn't a chase for the absolute peak floating point math. They're optimizing for two very different things.
Which are?
Performance per watt, and maybe more importantly, memory capacity per dollar.
And that choice tells you everything about the use case.
It tells you it's all about AI inference running models that already exist over and over at huge scale, not training new ones. So they can just get rid of huge parts of a traditional GPU, like rasterization for graphics.
And they're optimizing for specific formats. The sources mentioned INT8 and BF16. What does that mean in practice?
It's a huge efficiency gain. Think of it like this. When you train a model, you need high precision, like an FP32. That's a big, detailed paintbrush.
Okay.
But once the model's trained, you can run it through the inference with a smaller, less precise paintbrush, like INT8. It uses less power, less memory, and it's way faster without really hurting the final result. Baltra is built for that.
And the rumors on core count are pretty wild. Up to 640 GPU cores. That's 8 times an M3 Ultra.
It's a massive number, but that's not even the most interesting part. The real game changer is the memory strategy.
This is what I really wanted to get into.
Right, so every other high-end accelerator out there, it runs on high bandwidth memory, HBM.
Which is super fast, but has its problems.
Huge problems. It's incredibly expensive. You don't get much of it. An H100 has 80 gigs, and the production is totally bottlenecked by TSMC's CAOS packaging.
So Apple is just saying no to all that.
Yeah.
And leaning on their M-series playbook instead.
Exactly. They're taking that unified memory architecture and scaling it up for the server. Baltra uses wide interface LPDDR memory, probably LPDDR5X or maybe even LPDDR6.
Okay, but what's the trade-off? The sources say the bandwidth is a bit lower than an H100. We're talking maybe 2.5 terabytes per second versus over 3.3 for Nvidia.
It is lower, but the capacity advantage is just
Yeah.
massive. We're talking projections of 256 GB, maybe even 512 GB or more of unified memory right there on the package.
So does that lower speed matter if you have that much more space?
For inference, it might not. Think of HBM as a super fast two-lane autobahn that goes to a tiny parking lot.
Right.
LPDDR is like a slightly slower but massive 16-lane interstate that goes to a parking lot the size of a football stadium.
That's a great analogy.
For these giant AI models, the real bottleneck isn't always the peak speed. It's the delay from constantly swapping parts of the model in and out of that tiny parking lot.
So if Baltra can hold the entire model in its giant memory,
You eliminate all that swapping, all those multi-chip delays and PCIe bottlenecks just vanish.
Yeah.
That capacity becomes a huge performance win for inference. It's cheaper and it's faster where it counts.
and to build this, they're obviously using top-tier fabrication.
Oh, yeah. TSMC's N3 node, probably N3E for power efficiency, but then you have to connect all these chips together, and that's where their collaboration with Broadcom is so critical.
Specifically with SerDes technology. You
Mhm.
mentioned SerDes. Okay, for those of us who aren't microchip engineers, what exactly is that?
SerDes stands for Serializer Deserializer. Just think of it as the ultra-high-speed courier service inside the data center. It takes all the data running in parallel inside the chip and converts it into a super-fast serial stream to send to another chip with almost no errors.
And Broadcom are the experts there.
They're the best. This ensures that when Apple links, say, 20 Baltra chips into a cluster, they all talk to each other seamlessly. That low-latency communication is non-negotiable.
Okay, so we've got the strategy, we've got the hardware. Let's put this up against the competition, starting with the big one, Google's TPU.
Right, so the TPU and Baltra are designed for fundamentally different jobs. The TPU uses what's called a systolic array. It's tied to TensorFlow or JAX, and it is built for one thing: massive scale training.
Connecting tens of thousands of chips.
Exactly. Baltra is all about inference. It's tied to Apple's own ecosystem Metal, Core ML, and it's focused on memory capacity for efficiency in smaller clusters. Different philosophies.
And what about against a public cloud provider like AWS? Their Trainium and Inferentia chips.
The difference there is commercial. AWS has to serve everyone. Their chips have to be general purpose, compatible with everything.
A jack of all trades.
Right. But Baltra is a private asset. It only has to run Apple stuff, like their Ajax model. That lets them customize the hardware to an extreme degree.
Which has to lead to a huge cost advantage.
A decisive one. That vertical integration, using cheaper LPDDR memory, it should give them a much better unit cost per inference. That's how you scale this to 1 billion phones.
Now, the closest competitor seems to be Meta's MTIA chip. They also use LPDDR memory.
They are the most similar, yes. Meta also rejected HBM to get more capacity and lower power, but for a different reason.
Which is?
Their chip is optimized for their recommendation models. Think ads, news feeds. That's a very different workload from what Baltra is designed for, which is the really heavy stuff, large language models, diffusion models for image generation. That requires way more raw compute density.
So if you boil it all down, what are Baltra's unique selling points?
I'd say it's 3 things that are literally baked into the silicon. First, hardware-based privacy. That secure enclave on a server chip is something no one else is really marketing to consumers.
Okay.
Second, the unified memory architecture. Getting rid of those bottlenecks is a huge win for inference. And third, and this is key, supply chain flexibility. They are deliberately avoiding the HBM and CoOS choke points that are throttling Nvidia.
Let's talk about that supply chain.
Yeah.
Because the timeline is a bit fuzzy. Mass production is slated for Q1 2026. But users might not see the benefits until late 2026, maybe 2027.
And that's pretty normal. There's a big gap between having a working chip and having thousands of servers running globally. But the really big news on the supply chain is about the packaging.
Right. To get this to work, you have to package the compute dies and the memory super close together. The standard for that is TSMC's CoWoS.
Which is an incredibly high demand. There's a massive shortage.
And the sources say Apple is not putting all its eggs in that one basket.
Which is a huge strategic shift. They are reportedly evaluating Intel Foundry Services IFS and their advanced packaging, EIB, as a second source.
Wait, Intel? Why would Apple suddenly look to Intel for such a critical step?
It's a calculated risk to guarantee supply. EIB, or Embedded Multi-Die Interconnect Bridge, is Intel's way of connecting chiplets. Instead of stacking them vertically like CoWoS, it uses a tiny silicon bridge to link them horizontally.
So it's a different approach to the same problem.
Exactly. And by bringing Intel in, Apple gets redundancy. They make sure that the CoWoS shortage can't derail their entire AI rollout. It's a massive play for supply chain control.
And once the chips are packaged, who's actually building these servers?
All signs point to Foxconn, and crucially, they're building them in North America. The sources name Houston, Texas, and Jalisco, Mexico.
So they're diversifying geographically, too.
Big time.
Yeah.
It reduces risk and aligns with that Made in America push for critical tech. And the numbers are huge. Foxconn is apparently building lines capable of churning out 1,000 AI racks a week. This deployment is going to be massive.
So wrapping this all up, what's the final significance of Baltra?
At the end of the day, Baltra is probably the most important silicon project Apple has launched since the M1. Not because it's the fastest, but because it's a complete strategic reset. It's an economic and privacy play.
Right.
By driving down that cost per inference with LPDDR memory and controlling the whole stack, they're building a financial model that lets them give high-quality AI to billions of people, potentially for free, with a hardware guarantee of privacy.
So what this really means is that Apple is building its own fully independent AI supply chain. It's a parallel universe that completely separates them from the Nvidia ecosystem and rewrites the economics of cloud AI. And here's a final thought for you to mull over. If Baltra's huge LPDDR capacity lets these massive models live on a single server chip at a much lower cost, what does that enable for the next generation of your iPhone or your Mac? If those devices also get even more unified memory, it starts to blur that line between the cloud and your device even further. It could give Apple an advantage in truly powerful, truly local AI that competitors stuck with expensive HBM just can't afford to match.